Hello and welcome to Technical Utkranti, and today we will be going to see the question called as longest consecutive sequence. This is the 22nd question in the arrays in the data structure series, and soon we will be starting with linked list. Let's get ahead with understanding the question. You are given a list of numbers, and what is the biggest consecutive sequence of elements that you can extract from the given array. For example, here you have 1, 2, 3, 4. So this is the biggest set of the consecutive elements that you can find in the given array, right? So answer would be 4. Now there are two approaches of finding the answer to this problem. First is by sorting and second is by using dictionary. So let's understand the sorting approach. So we have array. I think this was the array. And what we'll do is we'll sort it. With sorting, the consecutive elements would come together. Now what we just need to do is we'll keep incrementing the counter until we find consecutive element, and as soon as we find that the element is not consecutive, we will reset the counter and start counting all over again. So over here we get count of 1, and again over here we get count of 1, and therefore we get the maximum count of 4. As you can see, I am iterating over the entire array, and for the first element I am just incrementing the count by 1, and then I am just seeing whether the current element is equal to 1 plus the previous element. If that's the case, I'll increment the counter. As soon as I find that the current element is not equal to 1 plus the previous element, I'll reset the counter value to 1. This way, I'll be updating my count at each element, and I'll be seeing that if the current value of count is greater than the maximum count value, then I'll be updating the maximum count value with the count value. All right, the count value of 1 and maximum count value also of 1. Then here I'll get max count value of 2, and since 2 would be greater than 1, max count would be updated to 2. Similarly, here I'll get 3 and max count would be 3, 4, 4. But here I'll get count of 1, and I see that 4 is not less than 1, or 1 is not greater than 4. Therefore, maximum count remains 4 only. Similarly, here it remains 4 only. So this particular variable tracks the value of the maximum count, and hence we get the maximum count in this format. Let's understand the second approach. In second approach, the idea is to store the elements in the dictionary. And as you know that we store elements in dictionary because in dictionary we can search the element in O of 1 time complexity. So this is a key and this is a value, and to begin with I'll just initialize the value of all these keys as 0. All right, the idea is to start with any element x and see if one less than this element is there in the dictionary. If it is there in the dictionary, then see that one less than this element is there in the dictionary. So until I find the element that does not exist in the dictionary, I will keep on doing this, and this way I will find that the length of the longest consecutive sequence starting from this particular element. All right, so I'll do this for all the elements, and in this way I will be able to find the length of the longest consecutive sequence. So let us just see this, how it will be going to work. Okay, I have 100, and I'll see if 99 is there in the dictionary or not. It is not there. So I will keep a variable called count, and which would be initialized to 1. And once I find that 99 is not there, I'll update 100 with the value of 1. Now I will begin with 4, and then I'll see if 3 exists in the dictionary or not. So 3 exists, the count gets updated to 2. Then I'll see if 2 exists in the dictionary or not. It exists, count gets incremented to 3. If 1 exists in the dictionary, yes, it exists, count get incremented to 4. 0 exists in the dictionary, no, 0 does not exist. So from 4, I get the longest consecutive sequence of 4. So 1 is updated to 4. Okay. Then comes 200. And for 200, I'll see if 199 exists. No, it does not exist. Count is 1. So 200 value goes to 1. Then for 1, 3 and 2. So if I do the same exercise for 1, 3 and 2, you'll see that I've already done it when I was doing it for 4. Correct? So I will just fill these numbers over here itself. So I'll fill 4 with 4, and then 3 with 3, 2 with 2, and 1 with 1. And I will just see that if the value of the particular key is non-zero, then I'll not be doing this particular exercise for that particular key. In this way, I will save on unnecessarily doing the operation for the smaller keys, given that the bigger key in the same sequence has already been operated upon. Right? So this way I will save on time. And second thing is that if I have done for 4, all right, and I have, let's say, one more element, let's say 5. So for 5, what I will do is I will start with the count value of 1 only, and then I will see if 4 exists in the dictionary. It exists in the dictionary. I will see that if the value of 4 is not 0, then it has already been operated upon. So I will straight away take the value of d of 4 and add it to the current value of count to get the count, I mean to get the count value of d of 5. So in this way, I save on iterating from 5, 4, 3, 2, 1 completely. So you got my point. We are saving the time in two ways. First is that if I have done an operation for a bigger element, I'll not be doing it for the smaller element by updating the value in the dictionary. And if I'm doing the operation for the bigger element and I have already done it for a smaller element, then I'll be using that value instead of doing the operation all over again. In this way, we do the operation just once for each element, and I get the time complexity of O of n only. But the space complexity increases to O of n. Whereas in the sorting approach, there was no extra space required. I hope this explanation was clear to you. Let's look at the code to understand it a little better. So, as told in the explanation, all the elements are stored in the dictionary with the value of 0. Then this max count is will keep the value of the maximum count at each iteration. Then count equal to 1 is initialized, and then I'll be searching. So forget these two statements for now. Just look at this. So if I'm finding one less than the current element in the dictionary. Forget this also for now. These are optimizations. I'll explain it later. So if you find one less than the element in the dictionary, increment the count. And once you do not find the element in the dictionary, just update the uh, the value of the current element that you started with the count. Okay, all right. So this exercise you are going to do for all the elements, and then you see that if count is greater than maximum count, you update the maximum count. Now what is this code? This code is just to set the value of the smaller keys, given that the higher key is already found. For example, d of I is equal to count. Then for all the elements from I to the smallest element in the consecutive sequence, I'll be initializing it with its count. Okay, for example, I is 4, and we know that 4, 3, 2, 1 is the consecutive sequence that started from 4. So from 4 to 1, I'll be updating all the values in the dictionary for those elements 4, 3, 2, 1 with the proper count, because for 4 I've already found the count. Okay, what is this? So this is the same thing, that if I am starting with a bigger element, but for the smaller element I've already updated the count in the dictionary, then I'll just use the value from the dictionary and break off. I don't need to again count, all right? Don't need to do all these things all over again. And this particular thing is for the smaller elements. So as you know that for 4, if I had found the count for 4, and I have already updated that for 3, 2, 1. Correct. I have updated the dictionary for 3 to 1 as well. Then when my iteration reaches to 3 or 2 or 1, then I can straight away see that it has already been updated. Its values has already been updated. So I don't need to carry out the operation all over again. And that is why I am writing these two lines over here. So I hope that the code explanation, though it was a bit sophisticated, makes a little bit sense to you. So let's see if I can get the same answer and I get the value of 4. So if you have any doubt, you can drop in the doubt in the comment box, and do give it a like and subscribe. Thank you.